Now we use this idea of the least common multiple of a polynomial expression in the form of a denominator. So now we move into LCDs in rational expressions. And so you can see here in example number 1 that we have a situation where we're adding two rational expressions to each other, and we really need to get a common denominator so that we can add the numerators together and then put that final value in simplest form. It also asks us to state any excluded values or restrictions on the variable. You remember that that's just simply any value that will make any of the expressions undefinable. So if we look at this, the first thing that we did in this first step is we actually factored the second expression, and we can see that we have a common x minus 1. But the first expression doesn't have an x minus 2, so that needs to be applied as a common denominator to the first expression. And you can see in the second step in red where we did that to both the top and the bottom, very similar to what we did when we were adding 1/2 plus 1/3. So once this is done and there's a common denominator between the two rational expressions, we can actually combine those under one denominator and then proceed from there to simplify the expression as far as we can. Now, if you look at the final answer, x plus 1 over x minus 2, we see that x cannot equal to 1 as an excluded value. Now, that may kind of not make sense right off the bat, but if you look back to the original problem, you can see we had x minus 1 and x minus 2 and the denominators between the two rational expressions, and so we have an excluded value of x cannot equal to 1 and x cannot equal to 2, because in the original rational expressions it would make those undefined, and you can't add undefined fractions to each other. So you're not just looking at the simplified final answer, you're also looking at the denominators of the original expressions. Okay, so what I'd like you to do is go ahead and give sample problem number 2 a try. Come back, take a look at the solution, and then from there you can move on to sample problem number 3 if you feel like you're understanding very well, and then watch the solutions on that as also. And we can see very clearly that x minus 1 is the same, but we have an extra multiple of x that needs to be applied to the first expression. So I'm going to multiply x to both the numerator and the denominator, and I'm going to go ahead and work out that particular operation. Now you can see that we have a common denominator, and so I can add the expressions in the numerators and put it all under one common denominator. Once I do that, it's probably a wise thing for me to just go ahead and factor the numerator in full and then simplify. Leaving me with x plus 2 over x is my simplified answer. Now, let's keep in mind here that I have to go back to the original parts to get my restricted domain, and so we'd see that x cannot equal to 1 or 0. Okay, so that's a simplified version of adding two rational expressions. If you felt good about that, go ahead and try sample problem number 3. So as we start sample problem 3, you can see I've quickly factored the denominators, and we have 3 separate parts. We have an x, we have a 2, and we have an x minus 2. Now the x minus 2 is common in both, so there's really no adjustment that needs to be made there in those denominators. But we need to multiply 2 to both the numerator and denominator on the first expression, and we need to multiply x to both on the second expression, and so I'll go ahead and do that now. You can see from this result, now that I've applied the least common denominator to both rational expressions, I've come up with a subtraction problem that has the same denominator. Now, keep in mind, since this is subtraction, when I combine these together under one denominator, that negative actually has to be applied to the whole expression in the second part. So I'll go ahead and do that now. Okay, now we've gotten this to a place where we can start to eliminate and simplify parts a little bit, and so I'll just go ahead and move forward from here. You can see that the two x's are going to cancel each other out on the numerator, so they don't cancel out with the denominator, however, because the operations on top just eliminate them. So we're going to be left with negative x squared plus 4 over 2x times x minus 2. Okay, from here we're going to actually take out a negative 1. We're going to factor out a negative 1. And then we can see that this leaves an x squared minus 4, which gives us a simple difference of squares problem. And now we're left with x minus 2's that can eliminate each other. And I'm going to distribute the negative 1 back across there for my final simplification, leaving me with the following expression. Now, we need to state our excluded values. Clearly, x cannot equal 0 here, but if you go back up to the original rational expressions, we had x minus 2 in the denominator, so x can also not equal 2. So our restricted values are 0 and 2 in this case.